Hello, I'm David Hochhauser, Chief Revenue Officer for Hub Security. And with me is Fay Arjomandi, the founder and CEO of Mimik. So as a brief background, Hub Security, we're a cybersecurity company. We design our own hardware and software, and we're focused on secure edge computing. And we leverage a new security paradigm, something called confidential computing. Mimik provides the industry-leading edge application development platform. And in a minute, I'll let Fay fill you in a little bit more on that shortly as well. So welcome to what I think will be a fascinating discussion on what is really an extremely relevant and current topics around edge computing and IoT. And just to give you an idea of how relevant, I was just looking the other day at a stat, and IDC is looking at worldwide spending on edge computing to reach $250 billion in 2024, which is a huge market. And so it is rolling out much faster than I think most people realize, and will dramatically impact the computer industry, as well as each of us individually. And a couple of things of what's really kind of sitting behind this trend. And I think there are several things, there are several technologies emerging that are all starting to come together. So you hear a lot about IoT, you hear a lot about 5G, AI, cloud and edge computing, and each by themselves has massive potential. But together they're really absolutely game changing. And so what's happening is the amount of information, processing power, you'll see 5G is bringing data faster to everyone. IoT is just bringing dramatically more information from dramatically new sources. And then you add in cloud and edge in the direction of where edge is going, and you'll see computing is occurring literally everywhere it's needed. And two key areas why Fay and I are on is actually two extremely important considerations in this area. One is security. So you'll see typically security, we're just adding more and more layers and patching together and putting things on top. And this rapid pace of new tech is really bringing entirely new and increasing security and privacy threats. So it requires an entirely new cybersecurity approach instead of the old approach of patching everything together. And if I look at it driving it all, the applications in AI is making sense and putting use of all this vast amount of information, often in real time. And if I really look at it, the reality is, without the applications driving it, the rest of all of these trends is just academic and just a bunch of technology. So with that, I'd love to get some thoughts and input and really get it from Fay directly. And I'll start off kind of with the first question that no matter when I talk about this topic that comes up all the time is kind of how do you define edge computing or edge versus IoT? And what would be your definition of how you would explain that? So Fay.
Sure, and thanks for having me, David. So edge computing is really about the ability to process data where the data source is, or at the closest proximity to where the data source is, right? So to me, IoT is an application on top of edge computing, or an industry sector that utilizes edge computing. It's almost like we say the difference between web versus cloud computing, right? Web was utilizing the cloud computing in order to deliver the experience or the product into market. And really behind edge computing is really, I think there are three trends that is making edge computing a relevant and in fact a necessary element. One is that connectivity is going to be everywhere. The second one is compute is going to be everywhere. Like every device is going to have more and more compute, storage, memory, CPU, computational ability. We're going to have data produced everywhere because web was about, or mobile internet, they started about device connect to web, consume content. But now with IoT, with the smart things and with autonomous world, data is going to be produced more and more on these devices. So it's not just about consumption. So these are the three elements, in my opinion, that actually makes edge computing a necessary element, because data source is at the device, and the knowledge to what to do with that data source a lot of time is going to be at the device level as well, or two devices that are within the proximity of each other. When you talk about IoT, you're talking about a sensor communicating with a robot, and a smart camera, surveillance camera, can detect an intruder and inform the security person of that intruder. So a lot of time, it's about IoT, is about a collection of devices that need to take an action or monitor or observe based on what they monitor and based on what they observe. So it makes it, in edge computing makes it a necessary element to create a much better IoT and deliver them more successfully at lower cost, lower latency, with more security, with more data privacy. That's the relationship between the two, in my opinion.
So that's interesting. In those examples, and sometimes I simplify, a little bit. I just say, basically think of edge. The computing part is anything that's not happening in the public cloud is somewhere else, is happening on the edge. It could be a local data center, but it can also be literally on premise. And I guess the IoT device is actually the device at the end. I would separate that as the endpoint device, and everything else. That's where I see it playing out. Depending on the application, the edge processing is occurring everywhere else, and we still haven't seen, will it be mostly at an access point, mostly literally on the premise, or will it be in a local data center? I feel it's going to be everywhere.
I think it's exactly to your point, David. It's everywhere. It's compute is going to be everywhere. Now, the definition of edge, I guess, again, if I say edge starts from where the data source is and goes to then the next point, which can be a gateway, which can be an on-premise data center, which can be a base station, compute available at the tower, right? Now, then you go, I guess we have to start from where the data source is and say, this is edge. Yeah. And now everything between them and every other compute on the path can and will have a role. And to some degree, we may have to actually reference this more as a distributed computing, where data and the operation on data starts at where the data source is, or the closest proximity to where the data source is. And they always will exist. I mean, they always will coexist. The endpoint device with a gateway, with an on-premise data center, with even the public cloud, will always coexist. And depending on what the operation is, the right computing point will be utilized for it. And that's actually one of the challenges of what we're facing, because if you think about cloud computing, is provided us with a homogeneous environment that I'm not worried about what is the network, what is the operating system, what is this. I just host my service on that homogeneous environment and I can access it. So, but when you think about edge, it's very fragmented. It has different, it has different operating system. It has different type of compute. You have different type of connectivity. So therefore, it's very heterogeneous. And how to create a homogeneous environment out of this heterogeneous environment. So at the end of the day, the developer or the solution provider can see this as a seamless computation available to them. And whether the macro service now need to be on that iOS, or as processing need to be on FreeRTOS macro controller, or instantiate a process on gateway at the premise, or instantiated in public cloud, for developer is the same. They look at it as a seamless computing available that they can utilize it. That's what Mimic has done, by the way. It's kind of creating that homogeneous environment out of the heterogeneous situation, so developers can just seamlessly run what they want to run.
And and to me, that's what I think is critical, because I think that's what gets people. It's confusing because the cloud was easy, as you said. In one sense, everything's in one place. You get it, you understand it. The edge is all over the place, and that distributed computing and lack of homogeneity is very confusing to people. Those kind of tools, I think, will be critical.
Absolutely.
To actually roll it out. So let me ask you, why do you think today so many, we're hearing so much about it today? And kind of related to that, I guess, is maybe what kind of examples and applications you're seeing, because that may tie into why we're seeing it today, or what are some of the first ones even coming out versus what you see down the road as well. So there's a bunch of questions in there, but I kind of have all of those topics. So
sure. So I guess the reason people are talking about it a lot more is, first of all, we always saw this trend coming, right? We're moving from mobile internet to this notion of hyper-connected world. Mobile internet, you have a mobile device and you do things on that mobile device. But hyper-connected world is about, again, everything is digital, and your digital and physical space somehow interlock, and you move between physical to digital, digital to digital, and back and forth, because every process now has a digital presence, including you yourself will have a digital twin. People talk about digital twin, but in reality, it's a digital twin of every process, including even individuals. And when you go from and mobile internet was just the tip of iceberg. People think that it was revolutionary. It was revolutionary in its own kind of world, but now hyper-connected world, as every technical trend is converging at the same time. And COVID accelerated that. Like when you were talking about edge or even digital transformation, a lot of businesses used to say, why should I go through digital transformation? Or I have time, let me process it. But COVID over the night proved the business demand for digital transformation. Now there is a race happening, because now those who are digital native or who've been digital natives, those companies who've been digital native, they have a advantage in capturing more market, which only was 20% of industry according to Gartner. Now you have 80% of industry that just going through that digital journey, going through that digital transformation. And then you have AI, you have smart mobility, you have robotics, you have blockchain that are going to be embedded in everything. So we're actually moving from vertical application world to a horizontal, what we call contextual aware software defined systems. So it's no longer going to be a vertical application. And I give you one example, if I may. If I am in a financial domain and I'm asked about my health situation, it's probably because somebody wants to know what's my mental health situation, so that they can give me a loan or not. If I am in a financial state, a health world, and they asking me for my financial world, they want to know whether my mental health is having a role in my depression. So it's context, and it can't be one vertical application. It's really movement of knowledge across this domain that makes it more moving from vertical to horizontal.
That's interesting. That's actually interesting that you see it across. A few thoughts on that. So one, because I'm seeing people focus initially starting out horizontal and then envisioning here's all the vertical stuff. So, speaking to somebody the other day who's doing a healthcare application, besides gathering all the data, they start doing applications for diagnostics in individual hospital. Then they start sharing it across a hospital. Then somebody's actually looking for the medical record. They're writing an application to put it on the blockchain. Then they'll start taking that application, as you said, and they could start using it in different contexts across It seems like there's a stepping stone to get along the way. And some industries, I mean, there's a huge emphasis, now on critical infrastructure, on automating industry, doing, besides healthcare, the automotive industry is the classic example, of that kind of thing. But even things like I'm seeing certain vertical solutions like agriculture and ag tech, there are drones out there automatically monitoring irrigation and tractors automatically irrigating farms. Now you have to look at swarms of drones and collate them and look at all that information and how you analyze it and bring it back. And then it starts feeding down into the rest of the supply chain. So that's an interesting perspective, because I see the use cases easily going across industry, and I also see them vertically, but I wonder if vertical will start off and then they'll go across industry.
It's exactly that, because I think the personas are different at any time based on the context. You mentioned automotive, right? So think of as automotive, when the car is parked in your parking lot or garage, can be a computational node for other tasks, can mine your blockchain, example. Right. But when the car is on the road, is part of a cluster, a swarm of other cars that they need to communicate with each other. And the car itself is not just one computer. The car itself is multiple computer node. You have the main core computing, you have the sensor as a computer. Actually, in edge computing is or distributed computing, or call it hybrid edge cloud computing. It's very important not to look at it from the cloud view, that you have a central compute and everything connect to it, because every element, every sensor has its own computation as well. Now you have a main domain controller, you have an infotainment computer, you have the passenger mobile device that it's sitting in the car, and then that automotive need to communicate with other automotive. Now, it communicates with other automotive in order to decide on traffic or traffic optimization, or inform each other of an incident. But then as the car pull into a charging station, now is part of V2X, right? And it's about, hey, I need to pay a transaction fee for my charging station. Where that transaction fee goes? Does it go to the car? Is it go to the driver? If this is a car as a service, what happened versus if this is a car that I own? So the context and the personas are constantly changing. And that's why, again, it's more horizontal. Now, that doesn't mean that you're not going to have an experiential layer for each one of them, but think of those experiential layer are processing or receiving knowledge from multiple computing nodes that can be on the same car, it can be within the proximity of the car, it can be attached to the same network. At any time, these personas are changing. So that's why it's to us, is like cloud layer, cloud computing layer. Then you have your macro service layer, which is the standard way of developing cloud native with RESTful API. And RESTful API must be in the game, because they are like the handshake, the standard handshake for interoperability, the same way that HTTP was a standard handshake of the web. So, and then it's a business logic. So how does this business logic is going to utilize these macro services on the same device, across the device, within the cloud, outside the cloud? That's how, and interoperability is so key, because we don't know what we don't know yet, right? And in order to evolve and interact with the world cross-domain, we need to have that RESTful API everywhere and kind of a standardize on the architecture, which is macro service level, separate data from the software so that you can process it and draw knowledge from it. And then a business logic will use it.
It's fascinating, because we obviously got it. One's coming from the application, one's coming at a security perspective. And we see very similar approach. One, all that processing you're talking about, depending on the use case, is going to be done in multiple places, right? The car, computing in the car, it's going to do transactions with computing outside the car. There's going to be analysis done in the car, multiple cars in traffic where the analysis. So the computing is going to be done in multiple places. The other thing, and I'm curious to ask you, I've had some thoughts on that, is from a privacy and data and security perspective, sharing that data across different verticals or protecting that data and protecting even the APIs. I was curious what your thoughts are on some of that as well.
Absolutely. So the security and privacy are actually one of the key, very important factors of our future as we enter the digital world. And the way we looked at it is that, okay, the world is going toward being autonomous. Therefore, you need an autonomous cloud as well. And this autonomous cloud, that's why we call it kind of, we reimagine the cloud. Mimik has reimagined the cloud for the autonomous world so that you can develop a smarter application, more secure, more data privacy. Why? Because today we have a tendency of pulling raw data and pushing it in one place, in a central place, and then go and operate on that data. Within the enterprise, we have more control. Within the consumer, we have less control. Every day, we input information in 100 places that we don't even know how they keep it secure or private. Within the enterprise, especially on IoT that you're talking about, the data avalanche effect is a huge issue. In fact, a lot of IoT implementation were dismantled because sensors are just sending data blindly. But now, if sensor has the information that say, hey, if I observe this element, I need to encrypt the data right there. And instead of sending the raw data, maybe send the knowledge to another endpoint. And I will define my scope that you only can see this part of data, or this part of knowledge, not everything. So you kind of deciding on the node, and because your knowledge is now, you separated raw data and you're sending knowledge, you can now do more operation on that knowledge at the end, at the second level, at the next endpoint, right? And you can make decision faster. I'll give you one example on unstructured to structured data issues. A lot of, like, I come from telco background, so it was always an issue that now that I have an unstructured data in the database, I need to do operation on that unstructured data. And because it's raw unstructured data, you can't just simply look at it. So there is a lot of operation need to be done first to anonymize it, process it, make sure that the person that does the operation doesn't look at the data. And by the way, it's the same in healthcare, it's the same in financial sector, so that they don't look at it and then start structure it and push it to different databases. When you have edge, you can make that decision from edge based on the policy of data, based on the policy of privacy, policy on security. You can say this piece of knowledge can go to that point, but the other piece of the knowledge should go to the other point, right? And when you have that separation of data from system or knowledge from system, you have to start doing operations such as, hey, I'm going to operate on encrypted data. It's therefore something like confidential computing, right? So, and I think again, these are all the reasons why enterprises should look at the world from that view of distribution and separation of data from solutions, operating on knowledge, respecting data security and privacy, and standardizing on their architectures of microservice and API, and then move forward. In order to stay relevant, and in order we make a joke to have a kind of, we make this comment that that's the only way to get an edge in the market. Differentiation, right?
And that's interesting because actually, and just specifically, what Hub does to actually complement that. One is you really don't know, the computing's everywhere, so you almost need a secure data center wherever you're going, because you never know, somebody could pick up, walk away with the device. Protecting the applications coming from all over. Sometimes they're sitting behind a secure data center, sometimes not. There's two aspects to that, from the data and from the API perspective, that caught my attention as you were saying that. One, from the data, I agree, that's interesting. From the IoT, has the choice of where it sends to what. The other thing confidential computing allows you to do, though, is once you do want to collate some of that data from multiple parties, it lets you not have to do the de-identification and the anonymization, because we could actually put things, it creates secure enclaves around the data and the applications themselves. So people could actually share the information, share the application. Never anyone can see each other's information, but they could share the results and the insights coming out of it at the end of it. So it leaves another type of application that you can do by protecting the data, whichever stage that it's in. You could put whatever degree of isolation you might need around that application. Healthcare is the most common thing. You might have healthcare data coming from multiple devices. It comes in, you collate that data, because you actually want, the more data, the better it is. That data may go to multiple places. At some point, the collation of the data is coming from multiple hospitals coming in and doing diagnostic information. But the hospitals don't want to let you don't want to have to, you have to protect the privacy of that information. If you do it right and create the enclaves, you actually don't have to go through that effort of privatizing it. You could do it by creating secure enclaves around each data, sharing it and sharing the results. So it depends what stage of the application, which piece you're actually doing at what point. So there is a part that collates it together, part individually. The other piece that's out there that at least we do from confidential computing is we actually create a digital image of the entire environment. We never let anybody get to the actual hardware, application, data, even hypervisor. We actually create, where there's normally a digital image of a physical object, we're creating a digital image of the computing environment. So even if somebody gets to the system's password, they can't get through to the actual system. So what that enables you to do is we're essentially protecting the REST APIs. And so somebody is never actually getting to them. They're getting to, we're putting control in front of that series, in front of that application to the APIs, and completely isolating the application. It's something called protecting it while it's in use, versus also protecting it while it's transporting it there, and while it's sitting in, and while it's also at rest. And so the new part about it is protecting the entire computing environment while it's actually running. And that's what enables us to actually take that application and run it securely. No matter where it is, we can protect that application. And no matter where the data is, we could actually segment and isolate the information as well. So it does play into, you need that kind of flexibility, because again, it's so dependent on the use case and where this application is running. So, but where, from a security perspective, making sure that doesn't occur, that at least is protected no matter where you actually place it.
Exactly. And the scope is the most important element. Like the way we usually analyze it is that in your home, you don't have just one door. Every room has a door. Every closet has a door, right? With a smart home and a smart IoT, you will be able to even limit the access to every door and every, cabinet and all that. So data is the same thing, right? You don't just put everything in one place to protect it. You make sure that every transaction is protected. Every transaction requires a token, and every scope of that data requires a token in order to access it. So absolutely, it's about basically, and again, that's what makes Edge so important, because you can apply these rules and you can develop ground up with that model from where the source of data is, where the application is, where the usage is.
Yeah, and I was laughing a little bit to myself as you were saying that, because it depends on the strength of the lot too, because I had a contractor here who said,
Right.
Yeah, you know what? The lock on your front door, that would take me about 2 seconds to break into. And it's kind of a very false sense of comfort that people have by putting a little lock on their front door. It doesn't really take much. So I was,
Yeah.
as you're using that house lock, I'm thinking, yes. So it just really depends on how strong that lock is as well.
Exactly. And the point is that if somebody eventually break that lock, they access your home. Now, once they're inside the home, would they have access to everything? So
Right.
it's only a matter of breaking that first lock. But if every door and if every section has its own lock, and in order for you to access everything, you need those tokens and you need those permissions and you need those scope, then you have more security, right? So it's not about just securing one thing, it's about securing pretty much everything.
Exactly. That kind of gets down what we look at, right? It's zero trust, but down literally to a transaction level to do that.
Exactly.
So I have one more question for you. If you're a company just thinking about starting out, any advice or suggestions to how you go about helping a company just wanting to get started on their first edge computing application?
I think actually yes, many advice, and in fact we're even helping a lot of startups to start their journey on Mimic platform, and generally speaking, we call it on the right architecture. I would say start with the right software architecture. Adopt microservice development and delivery and RESTful API first, which is a standard, you know. And when you start with that, you can start looking at your doing microservices from starting from front end all the way to back end. RESTful API gives you the future interoperability. Don't undermine security first and privacy first approach. Unfortunately, a lot of startups are getting advice from their VC that don't worry about the scalable architecture, don't worry about security, don't worry about privacy, just go to market, prove your business model, and then figure out your security, privacy, and all that. And that turns into what I call a technology black hole, because you just throw money at your technology and you reach a level that now you have user base or enterprise wants you to add this feature and that feature. That's when you're gonna get issues with your technology architecture. So I would say look at your business, like map your product feature set, map it to the right architecture. So the right architecture allows you agility, security first approach, privacy first approach, and then go from there in an iterative fashion. It takes maybe longer to start, but then it helps you when you're scaling and accelerate your scaling stage.
Oh, that's good. And often people do cut out those first steps thinking they'll get there quicker, and then they end up taking longer, essentially.
Exactly. What happens is that you, especially because you mentioned startups, especially when you're in a startup, you're almost like a role model for other startups. You're giving idea to the market, and you're giving idea to other startups, and you're giving idea to other large companies. So you pretty much, if you're not thinking through these steps, you basically giving information to the rest of market in how to compete with you in a better way. So that's why it's so important. And for large enterprises, is that they have to also adopt this model, because it allows them to still compete in the market much faster and better and lower cost. Because the cloud native people, and the reason I'm calling cloud native people is basically, or digital cloud native people, that basically they started with cloud from the ground up. They already have adopted microservice development. They already have adopted RESTful API first. They already adopted proper security, so they can get to the market of the current enterprise much faster. So if the enterprise doesn't take these things into consideration again from ground up, they are going to lose in the market, and they're going to lose their relevancy of future.
Interesting, right? So It is a matter of planning first. And I see, and even the big cloud providers are moving, they're extending their cloud out to the edge as well. And they're all moving in
Exactly.
that direction very rapidly.
Exactly. Cloud to the edge. So cloud to the edge versus edge first to cloud has a huge difference, right? Because cloud to the edge, the cloud providers are looking at, I'm a data center provider and let me build a data center at the edge, and everything needs to be connected to that data center. When you look at cloud center view in the car, you put a huge computer in the center of the car and you say all the other devices are dumb. So cloud provider is about endpoint devices are dumb, I'm the brain. But the distributed computing, and with the amount of computer that is available and becoming more and more available on this iPhone and every other device and your Nest computer and your Alexa at home, why not utilizing them? They are not dumb device anymore. They are a smart device. And when you look at the move from likes of NVIDIA, that they even add a special chip into there for like add the special AI chip and all that, these devices are no longer dumb. So you can't look at edge with the way of cloud out. You have to look at edge with the way of edge in. Every device is a computer node. And now, how can these things coexist and communicate with each other? And data center and cloud is a node itself. It just have more computer.
That's interesting. I didn't quite ever look at it at that. I didn't quite look at it at that perspective. I like that. That's very interesting. The conversation's been fascinating. I think we're kind of running out of time. So
Sure.
just want to thank you, because it's actually really a fascinating discussion. And I'm sure we could go on well longer than half an hour.
Oh, yeah.